Now we're going to identify linear and nonlinear functions from equations and kind of see what they are. Notice that if you recall from the last example from in the last video, which was the first example, is that x and y both have to be to the first power. Notice that these are both to the first power and they are separate, so they are not together. There is no x times y. They're not in the denominator, they're in the numerator. So this one right here would definitely be linear. Looking at this one, notice that y and x are also to the first power. Those would be linear. This one here, y is to the second power. We can easily see that that is nonlinear. Now this other one looks confusing because it looks like that x is to the first and y is to the first as well. However, if I distribute that through, it becomes 8x, and then I multiply 4x times y, that becomes 4xy. Because the x and y are multiplying each other and are together, then it's nonlinear. It has to be separate. Notice in all these other cases here, just gotta fit it in perfectly. Notice in these other cases here, x and y are not together at all in these linear examples. So that's what they are. That's how I would see them from an equation. So that's what we see on that one. Okay. And let's move on. So identifying them from graphing, that's really straightforward. So this is probably the simplest way to be able to graph them and see what they look like. So notice in this case, Marta is driving from Seattle, Washington to Dallas. She records the distance traveled after various numbers of hours in a table. So in 2 hours, she goes 86 miles, in 3 hours 129, in 5 hours 218, in 6 hours 261, 9, 10, and 11. You can kind of see that. So which statement best describes the function that models the distance traveled? So is it linear? So notice here that between 2 and 3 hours we go about 43 miles. Okay, it's a little hard to see that exactly. It looks like in this hour we also go 43 miles. But here, between 9 and 10, we stop. So because we stop, we go no miles, which means it's not going to be the same distance that we travel in that one particular hour as all the other hours that we were going through. So therefore, it has to be nonlinear. So it cannot be for sure C or A. So the function is nonlinear because it's discrete. Well, it's not discrete because if we were driving, we have to drive between all the different points. That doesn't make any sense. And so it has to be because she travels 43 miles between 2 and 3 hours and 0 miles, which is exactly what I pointed out. Between 9 and 10 hours, there are different numbers of miles, which means there's going to be a different change in the slope of the line if it were a line. So it has to be B. And that's what we get. So I am going to reset that, and I believe the next video or the next part of the presentation that comes up is a check. And now we're done with section 3 in module 3.